Yeah. Hello, good evening. Welcome to the week 11 live session of CS104. Hope my screen is visible and that I'm audible. If not, please leave a message in chat. Good evening. Okay, I'm assuming it's visible and audible. So let's get started. And before we move into today's contents, next week, week 12, is ideally the last live session that was supposed to be there. But today I think I got an email from the NPTEL team asking for an optional last live session, right? So it's meant to be like a revision or addressing your doubts or things like that, because in the week 12 session we'll again have the week 12 contents and the week 12 questions, right? So they have given that option. So but I kind of want to ask you guys, if you think first of all it would be beneficial to have a last live session before your exam. So this will be most likely after, so the next live session is 16th, and I think in that same week they have given me an option to take an additional live session. So first of all, do you guys think that would be useful apart from week 12? Yes, okay, that's good. Demo file of week 11. I think I dropped a note to the TAs. I didn't hear back anything on this, and I think I asked you guys to also raise it on the discussion forum. I don't know if you did, but after today's class I'll again follow up on that email. But please by yourself also ask on the this one link of PPT. Which one, the live session or whatever is taught in class? Which PPTs are you referring to? Okay, so week 11 PPT. Okay, let me check. Was anyone else able to access it? I see week 11 PPTs in the same drive link, right? The whole smart stream. Week 12 is a different story. So yeah, week 12 I'll tell you. So it's similar to what happened in week 10, right? Last year's week 12 was federated learning. This year's week 12 is a continuation of NLP. So again, there are no previous assignments that you can kind of refer to, and I think the slides are not yet updated. The slides are the old week 12. So actually, since you week 12 content is live, right? I think you guys will benefit if I share week 12's PPTs. So I will do that. I got access to them today, so I haven't yet gone through it, but I will do the same as last time. I will put it up in that drive folder and then just ping you a link. So that should help with let me do that right away. Yeah, I have done that. So I got only one PDF, so I think this should cover. I saw only 2 lectures, so I think this one PDF should cover both of them. So you can refer to this and then let me know if you have anything else. So there was a question about week 11. Week 11's PPTs I am able to see. So does anyone else have a problem with week 11 PPTs? I don't know about the demo file, that I'll have to check. Okay, you have the slides, great, then that's okay. So next week again, week 12, we will go through this new content and we'll see if you feel, I don't know when is the week 12 assignment deadline. Let me check that. Okay, that is 18th, so 2 days after next week. So we can't go over the answers next Monday, but if you feel it'll be helpful, we can do that in a later session. So now, okay, so the first thing is, you guys said you wanted a revision live session, so I can try and schedule that. But I would also like some topics, right? Because it's very hard to revise 12 weeks of content in one hour session. It will be very I won't get to teach anything properly. So rather than that, I would like to do a revision that's kind of more suited to your needs. So today what we'll do today, again I think there's not too much in terms of the assignment and the lecture. So I'll give you a slightly longer break, maybe 10 to 15 minutes, and please look through your entire week 1 to week 11. And even if you have some topics, like last class someone asked me about hyperparameter tuning, right? So if you have topics like that that you would like covered in this revision session, please put that on chat, right? Use the break to do this, because if you do it this week, I'll be able to confirm the live session. I'll need to confirm this week itself. So I need the list of topics today. If there are not enough topics, then I may choose not to do a revision session, because 1 hour is too less to do a revision of the whole course contents. So I will give you 15 minutes maybe in the break today, and then you can come up with any doubts. It can even be saying I didn't really understand the solutions to week 6 assignment or week 7 assignment, anything like that, but I wanted to be specific points rather than saying revise the whole course contents. PyTorch container, okay, can you also put the week number so that then I can go look at the lectures and figure out which parts you're talking about. So if you would like me to revise something, please give a week number and the topic, right? So I'll then put in the recap from that part and spend some time on it. So I'll give you a break so that you get dedicated time to do this, but please do this during this session itself so that I get some time to schedule and plan it out accordingly. So we will try to have a revision session. I'm not yet sure if it will be 1 hour or 2 hours, but at the minimum we will have 1 hour after next week's session basically. Okay, with that, let's get started. Any other logistical questions? I hope things are clear about the exam and all that. Any other questions before we get started today? Okay, if not, good. Hope you are able to revise things and you're able to understand most of the lectures. Extra session will, no, I have gotten a deadline of 22nd. So it won't be at the regular time. I will have to look at my schedule and what options NPTEL is giving me and then schedule it. But I think the week of 23rd exams are starting. So they don't want to have sessions that week. They want something before that week. So the last date I am given for the session is 22nd, which means that there's already a session on 16th. So the other session will be between 17th to 22nd. I'll have to figure out what day and time based on my schedule. Okay, one more question. Design principle for building high performance clusters, week 3. Okay, sure. So yeah, please look through whatever doubts and questions you have and give me a list like this, and I would like more and more people to do this, because that way it's representative of all your doubts rather than one person's questions. But yeah, we will get started today. So first we'll start with a couple of questions that were asked last week. So the first one was on hyperparameter tuning. So again, I think we went through this in an earlier live session as well, but we'll try and revise it again today. So parameters are basically the weights of the model, right? These are things that are updated during the training process. So during training, what happens? You have a model and you give it some input data, and it does a forward pass on this, it does a backward pass on this, and then it updates weights, right? That's the iterative process. This keeps happening through one complete iteration on the training data, which is called one epoch, and then again multiple epochs are run so that the accuracy improves, right? So during the training process, the weights of the model are updated. That's the main thing to remember. Yeah, so if you can focus on the class right now, and then I'll give you 10-15 minutes during the break to look through the doubts. That will make it easier. Otherwise, if you start looking through your notes now, you might miss what I'm saying, right? So we'll split it out clearly. So I'll definitely give you 10-15 minutes during the break today. You can use that to look through and figure out what doubts you have. So I was saying, I was talking about the difference between parameters and hyperparameters. So the parameters of the model are the weights of the model, and these are tuned or updated during the training process. But hyperparameters cannot be learned during the actual training process. These need to be fixed before, right? They control how the learning itself goes on. For instance, the batch size. I think in a previous session I was telling you about SGD, right? And there we spoke about what happens when the batch size is 1, what happens when the batch size is equal to the data set size, and so on. So we touched upon the fact that the batch size can affect the learning process itself. Similarly, learning rate is one more of those. Momentum, which you guys saw in an earlier live session, is also one of those. So these are what is typically done with these is before the actual training begins, there is a search done called hyperparameter tuning. So what hyperparameter tuning does for a given network, it tries to find the optimal hyperparameters. So for instance, if I take a model, so I think you guys have studied about ResNet briefly in some class. So let's say I want to train my data using ResNet, right? Now, even when I say ResNet, the model architecture is kind of fixed. You know how many layers it has, you know what are the connections between those layers. But things like these, the batch size, the learning rate, are not fixed, right? So before you can start the actual training, you need to do a search in the entire space to find out what is the optimal value of this, right? Now, what is the search space that we talk about? For batch size, for instance, it might be a very easy thing. So your GPU memory has some limitations. Let's say you have 4 GB of GPU memory, right? So as you increase the batch size of the model, the memory that it takes to train will also increase. So let's say when you put the batch size to 32, you hit this 4 GB of memory, right? So this 32 is the maximum batch size that you can have, and the minimum you can have is 1. So now your search space could be, if you are looking at, let's say, powers of 2, I'm just saying that it need not be, but then you would be looking at things like 1, 2, 4, 8, 16 and 32. This is your search space or your parameter space for batch size. Similarly, you will have search spaces for all the parameters, right? And this is called the process of finding this optimal batch size. Now it might turn out after doing this hyperparameter search that your optimal batch size is maybe 4. This is the batch size at which that fits in your memory, and that also gives you a very good learning characteristic, right? So this is hyperparameter tuning. Again, there are a lot of techniques to go about doing this, but it's kind of out of the scope of this course, so we won't go into that. Grid search is one very common technique that's used to find hyperparameters. You can look this up if you're interested. So this is about hyperparameter tuning. I'll look at the question on chat. Meanwhile, if there are doubts on this or you still don't understand, please let me know. Knowledgeable machine learning project name. It depends on what you want to do the project in, because again, with machine learning there are a lot of application areas. I would suggest you pick an application area. For instance, do you want to do something with video analytics? Do you want to do something with health or medical data? Do you want to do something with things like that? Good job is a little bit generic. There are a lot of ways in which you can define what is a good job, right? So I would suggest trying to narrow down your focus into first maybe one area. Vision is a very vision is probably the most common among all the other domains. So maybe you can start with that, try out some small thing, and then you can move to the other things, right? So you can do something with health, you can do something with video data, you can do, so that's one way of looking at it. Or you can try to look at various problem statements and pick something that interests you. That's also good. Or if you want to use some of the demos that are given in the course, then you can think about projects that you can come up with using those demos. And any of these, ultimately, as long as you're able to understand it properly and then be able to explain it, it would be suitable for a general ML job. Again, after that, if you're applying to an NLP role, you might need an NLP project. If you're applying to a vision role, you might need a vision project, right? So that you will have to see. But I think if you pick up a small project, you may be able to do 2 or 3 over the course of 6 months. So you can try that out. Any other questions on hyperparameter tuning? Okay, if not, the other question that was asked last week was to explain the numericals. I think I had one example in week 4. So the question asked was to explain these from week 4, right? So I want to re-emphasize that this is not very relevant to this course. Numericals like these, where you're asked about what is the output dimension of this layer or what is the input dimension of this layer, is not very relevant to this course, and you may not get such questions in the exam. But if someone is still interested, what we can try to do is have 2 or 3 of these in the final live session, the revision session, right? And this may be useful to you in improving your overall understanding of CNNs and how the input kind of propagates across the layers. So if you are interested in that, please drop a message on chat and I can look at this. And I also want to link this here in a previous course, in the GPU architectures and programming course that is offered at NPTEL. I had kind of solved a lot of these numericals, and that is there in this live session linked here. So if you want to go through this offline also, you can do that. And okay, one person says interested, and we will see, depending on the number of people who are interested and the number of doubts that I get, I might pick up 2 or 3 questions from this set of questions to explain in the revision class, in the 13th class. But that's not going to be directly relevant to this course. I again want to clarify that. So you need not spend time learning it if you are looking at it from the perspective of this course exam. Anyway, so let me know on chat and we'll proceed accordingly. So with that, we will move to the recap for this week. Any other questions or doubts? Okay, let's get started. So we start off with understanding what is computer vision, right? So broadly, if I talk about computer vision, we look at, so again, why the name vision? We look at images or videos typically, right? So these are all visual inputs that we look at, and the computer or the system looks at these inputs to derive meaningful insights or information from these things. Now, what are we referring to when we talk about meaningful information? For instance, I think you had an object detection in example in one of the previous classes. So if I give you a picture, right, where there is a car, there is a human being, and you are able to detect, you are able to draw a box around that object and label it. Let's say you are able to label this as car, you are able to label this as human, right? That is one example of deriving some information or some insight from this video, right, or this frame. So that's a very simple example of computer vision. Further, what can we do based on this? For instance, you can come up with a car counting algorithm where in every frame you count the number of cars and you're able to give some information about the number of cars over this time window, right? Or if this is deployed in an autonomous vehicle, there might be some decision made based on this insight. For instance, if the car is very close to you, you might decelerate in order to avoid hitting that car, right? So you could be taking an action based on this information, you could make recommendations based on this information. All of this is part of computer vision. So computer vision basically enables a computer to see, observe and understand just the way humans do. That's the broad idea. Did not complete any project in ML. Yeah, that happens a lot of times, but you can try that out on your own. The good thing about ML is there are a lot of resources on the internet where you can find small projects to kind of start off with, right? And like I said the other day, the important thing is to come up with a problem statement, then look at what model you can use for this, what data set you can use for this and things like that. And then ultimately you will be able to improve upon it, iterate over it and take it to a better stage. So what is not very useful is just implementing a random mini project that you find on the internet. For instance, let's say something like handwritten character recognition from MNIST, right? It's very basic. So you might find a lot of demos and lot of code around that, but that itself may not be very useful, right? Because you're not learning how to do something new. So I would suggest starting off with a good strong problem statement and then looking at some of these things and figuring out how you would use them. Okay, let's move forward. So so what is in a computer vision system? We spoke a little bit about the pipeline, but what are the various components of it if you had to think about it? So computer vision systems use cameras to get this visual data, right? For instance, this image on the right. Then they use some models, machine learning models, to process the images. For instance, you might use YOLO in this case to detect some objects. You might say this is a bus, this is a car. Then they have conditional logic to automate application specific use cases. So we spoke about some of those, right? For instance, you have some maybe car counting. That's an application specific use case, and you might do that using YOLO, right? So those are all, this is part of a computer vision system. The deployment of artificial intelligence to edge devices, which is called edge intelligence, facilitates the implementation of scalable, efficient, robust, secure and private implementations of computer vision. So again, we spoke about these edge devices in one of the previous lectures also. So you could do vision on the cloud, you could do it on the edge, right? What are some advantages of doing this on the edge? So you get a lot of privacy, right? Because you are keeping the data on the edge itself instead of sending it to the cloud for training. So the privacy part of it is one thing, and it might be a lot more robust. Let's say if you have in a limited internet kind of scenario, it might also involve security again because you are keeping the data on the edge and so on, right? So edge intelligence or deployment of AI on the edge has brought about a lot of these aspects. So you can not just run it on the cloud, but you can do it near the sensors where the data is gathered. Okay, moving forward to some types of computer vision, right? So you can think of it as acquisition, processing and analysis. This is the pipeline that we spoke about. So we get data in the form of images or videos, then we process data and then we do some analysis. So what are a few examples or categories of computer vision? Image classification. A simple example, give you an image, ask you what is it a dog, is it a cat, is it a horse, right? That's image classification. Object detection, again I give you a frame, detect maybe cars in it or detect all possible objects that it's been trained for. YOLO does that, right? That's object detection. You might also be doing emotion detection, right? For instance, in a video, these days there are a lot of these automated software coming up. For instance, when you give online exams, there is an automated software that's kind of monitoring your video feed, trying to figure out if maybe your eye gaze is shifting somewhere, whether you're copying from somewhere and things like that, right? Similarly, there might be emotion detection. For instance, automated interviews is one use case, right? Where let's say how confidently you're saying something or how well your communication skills are coming forth. Things like that may be used. Or you might be kind of trying to gain some insights from a movie clip where you're watching a person saying a few things and you're trying to detect what is the emotion in that dialogue, right? These are a few examples. You might also do face recognition. So this is one step beyond object detection. So one ability is being able to tell that there is a face in the frame. The next thing you might want to do is recognize if that face is somebody that you've been trained to recognize, right? For instance, if you had an automated doorbell system which also opened the door depending on who is there, then face recognition would be very important. Then you might do object tracking, where as the video moves, you try to follow the object in the video frame. So, and then you might do segmentation, which is trying to divide your image or your frame into different things. you might do a lot more video analytics. So all of these are examples of computer vision. So coming to what is specifically video analytics. So this is basically analyzing video data to detect and determine temporal and spatial events. So for instance, I could give you a query saying how many cars passed through this particular area from this time to this time, right? So assuming that you also get some kind of time data from your videos, you should be able to filter out the video to just that specific time window that you're interested in. Similarly, you can do something with spatial stuff too, if you're getting geographical coordinates, right? Or sometimes you can do that with just an image or a video too. So all of this comes under video analytics. So why do we need video analytics, right? It's basically trying to scale all these and trying to automate these things without having a person sitting and monitoring video feed. So once upon a time, even though there were CCTV cameras, there have been CCTV cameras from a long time, right? But once upon a time, if you went to a police control room, you would basically see people who are sitting and monitoring those CCTV camera feeds 24/7, right? And in a lot of buildings also where there was security, even today in fact, in maybe some small apartment complexes or office buildings, you might see people deployed just to sit and monitor the CCTV camera feed. But now, so that's a bottleneck, right? Because you need people to do that. And ideally you would want to automate it by using an ML model in their place. So that's again being done today. In fact, even if you buy a consumer facing CCTV camera, right, you get a lot of cameras that are maybe 1000 or 2000 and they work on Wi-Fi, and you can connect them and sort of use your phone to look at the video feed. You can actually configure them to give you alerts for, let's say, a person moving in the house. So if you lock up your house and go for a week, you can put one of these CCTV cameras and it will automatically process the video feed. Maybe it doesn't do it on the camera itself. Edge deployment that we spoke about, that's probably not there, it's done on the cloud. But it will give you an alert on your phone saying that, oh, someone is moving around or someone has entered your house. These things are perfectly possible, right? So this is kind of the use of video analytics. You're able to scale things. So you can put 10 cameras in 10 different places and not have a single person needed to monitor them, right? So again, here we have the example of crime calls and security measures. So in terms of security measures, again, it could be like home security or an office security. It could also be like monitoring crime, traffic accidents, monitoring overspeeding, things like that. Yeah, and it's the same thing that we spoke about. We need human vigilance. So a person sitting and watching this feed might fall asleep, they might step away. There are a lot of things that come because of downtime due to humans, right? Mistakes that humans make. So you can eliminate all of these. Of course, there's also the mistakes that models make, which is what your whole accuracy and explainability in AI try to predict and therefore minimize. But the broad idea is to minimize human effort needed for all of this. Yeah, I think we went through this also. Monitoring CCTV cameras, automated surveillance and analytics, yes. And gaining popularity as automated solutions are efficient, right? So if you can if you can buy a 1,000 rupee camera and then put it for 3 years, you definitely benefit by it rather than putting a security person for every single day and you'll have to pay them a salary every single month, right? And their time might be better used. So automation always finds popularity because it eliminates the human effort needed. Okay, let's look at applications again. I think we looked at this, but let's go over it once more. Face detection. So like I said, you could do people counting, you could do crowd management, and you could check for people loitering around areas where they are not supposed to, right? Similarly, in object recognition, you could find a missing object. So I'm not sure if you guys have seen, but I think there are all of those personal tags kind of thing available, right? Like Apple has its own, I forget what it's called, maybe Tile or one of those things, where for people who lose their wallets or their keys or their phones, it's recommended to attach one of these things and then again your phone communicates with it through maybe Bluetooth, and then if your object is missing, your phone will kind of be able to scan the scene and pick it up. So that's again an example for your missing object detection. And abandoned object detection, let's say in an airport someone leaves a briefcase and goes away, right? So if you're doing this closed loop sort of CCTV monitoring, you'll immediately be able to detect it and then take some security measures. Color based object detection, directional movement, yes, all examples of object recognition. Again, with a restricted zone, you could have intrusion detection. You could find out when someone is coming in. You could have geofence control. So this is again, let's say your wallet is only, so typically we all carry our wallets with us, right? They're in very close proximity of us. So let's say we forget and leave it at a cafe and we start walking away. So a geofence is basically, you can think of it as, okay, my pen doesn't seem to be there. Yeah, so you can think of it as a virtual fence, right? So let's say you are here and the object is with you. Let's say you kind of move away, but you leave your object behind. So if you've set a fence of whatever this is, let's say 50 meters, the moment the distance between the object and you increases to that 50 meters, you will get an alarm saying that you're leaving behind this object. Again, this can be done through things like Bluetooth. It can also be done through video analytics. And similarly, you have parking, traffic management, traffic violation, stoplight violation, traffic control. So all of these sort of behaviors that are not allowed can be very quickly detected and penalized. License plate detection, camera tampering, all of these can be detected. Some more. So you can have a UI where the user can kind of set parameters that they need. For instance, they might say, I'm only interested in this part of the room, right? So how does this help? It reduces your processing. Again, remember that you might be running this on the cloud, so you might have to pay as per the resources you need. So putting in this area of interest might help reduce your processing. Similarly, you might say, I'm only interested in objects that are this color, or objects that are present here, or objects that have a certain size, right? All of these can be set in an application. And yeah, again, as a result of this video analytics system, you get increased efficiency. So a very clear use case for video analytics is in smart cities, right? So a lot of applications that we spoke about are broadly in the areas of transport and security and things like that, which are all a part of this notion of smart city. For instance, a smart parking system, traffic management, a dangerous situation identification, vehicle counting, number plate detection, collecting evidence in case of litigation, etc. So all of these are valid use cases that are there as part of smart cities. In fact, there have been limited deployments where, I think Bangalore is one of them, Bangalore and probably Electronic City, where this whole traffic monitoring as in the central control room that they have is completely done using ML models. So there are a lot of projects like that that are going on in a nationwide sense to use ML rather than relying on human effort to look at these CCTV videos. Dangerous situation, I'm not exactly sure if this was intended in something, but for instance, one example that we discussed was an abandoned object left in an airport, right? So that could be a security threat because someone might have put an explosive and left it there, right? That's a dangerous situation. Or on the road, you might see somebody walking, crossing the road, a child crossing the road while it's not supposed to, right? So all of those are dangerous situations, potentially dangerous situations, or it might be an accident that has gone on, or some other thing like that, right? So you can come up with examples. I'm not sure if a particular thing was discussed in the video, I don't remember, but these are examples. Collecting evidence in case of litigation. So again, if you have, if let's say there's a court case saying that this person has been harmed in an accident, and you want to actually find out who was responsible, right? Because in an accident, typically there are at least two parties involved, and the two parties might have different stories, right? So you need a neutral third party to kind of resolve the confusion, and CCTV cameras and video analytics may be great for that. For instance, if you have video footage from an accident, litigation might use that as evidence and it might help resolve the case. So that's one example I can think of. There would be a lot more. Okay, so now coming to deep learning for video analytics, again a lot of the use cases and examples that we discussed, right? For instance, we said object detection. Typically YOLO or SST or one of those models is used. So a lot of examples that you can think of, use cases, DNNs have made it there. And it started with classic computer vision techniques, maybe very simple things. For instance, camera image gets too dark or changes drastically, you trigger an alert. This is very simple, right? You don't need deep learning to do this. You can take basic image processing techniques and do this. And ultimately it has evolved to DNNs, right? So now people do a lot more sophisticated analysis than just looking at whether the camera image gets too dark. In a very primitive stage, that used to be the thing that's done. For instance, you see if there is any movement in the image. If there is no movement, maybe you say that okay, this is a low activity period, and then you stop processing, right? Very small things like that. But now it's a lot more sophisticated thanks to the variety of DNNs we have for each of these tasks. Okay, before we move forward, any other doubts or questions? Let me see how much more we have. Okay, let's continue for maybe 10 more minutes and then we can take a break. So again, talking about video analytics, how does it work? So you have a video, right? And typically this is split into frames. So you can think of a video as a sequence of frames that are typically arranged together in a temporal order or in a time-based order. Then you take each of these frames and you give it to your video analytics program or software. So the program again processes frame by frame and gives you a result or an output. What is this result or an output? It depends on the application. For instance, maybe you're doing object detection, then your result or output would be a labeled image where you say that okay, this object is there and this object is a car, things like that. So again, coming back to object detection, so the idea is to locate objects in an image or a video. Frame means image. Yes, you can think of it that way. So typically the frame comes from a lot of graphics terminologies, right? Things like frame rate, frames per second. Am I still audible? I just got a network notification that it's down. Hopefully it's back. Okay. Is it any better now? If not, I'll try to change the network. Seems to be raining here a lot, so my internet is a bit sketchy today. Am I clearly audible? No. Okay. Let me see. It's okay for you. Can someone else confirm? Interruptions. Okay. Yeah, I'll try to resolve that during the break. I'll try to find a, maybe now is a good time to take a break then. I'll try to switch to a different network and then, okay, if it's okay we can continue, but in case you have a second occurrence of this, let me know and then we can break, and then by then I'll kind of figure out my network situation and reset it. Oh, it's breaking again. Okay, fine, then we can take a break now. It's 7:45, so you can take a slightly longer break as I mentioned today. Please go through any doubts or questions that you have, maybe go through the slides. So we can take 10 to 15 minutes, right? I'll be back depending on how soon I'm able to resolve my network connections. But please feel free to take all the time you need to figure out your doubts and questions, right? That will help structure the revision class. So I'll see you around 8 o'clock. Okay, hope all of you got time. Okay, I see some questions. That's good. Does anyone need a couple more minutes or is this all? If anyone needs the time, I'll wait for a couple more minutes. Otherwise, we can continue. Okay, if you need the time, please let me know, otherwise we'll continue. So we were talking about, and hope my audio is better now. I switched networks. In case it breaks again, please let me know and I'll see what I can do. Oh, it's better. Good. Okay. So object detection, which we were talking about, is to locate objects in an image or a video. Again, after you locate it, you can use it for a lot more things. For instance, you can count objects in a scene, you can track them across frames, things like that. Oh no, if you have issues with the network, please bring it up within 2 minutes. For everybody, right? Otherwise I have no idea, because I do a network test before starting the call, but over the 2 hours itself sometimes the quality goes down. So unless you guys let me know, I have no way to figure out. So please let me know, all of you, right, anytime during the class. That's the reason I have 2 networks, so I'll be able to switch most of the times. At least one of them will work fine, so please let me know. Okay, good. Let's see. So yeah, we've spoke about object detection. The next step that you can do is object tracking, right? So here what you do is you take an initial set of object detections and you develop a unique identification for each of them, because the requirement here is that you need to be able to track something across frames, right? So let's say I detect a car here, right? And in the next frame, maybe the car has moved to this part of the video, or there is another car here. Now when I'm talking about tracking, I'm talking about this particular car itself and being able to locate that across frames. So you need to be able to generate a unique identification for each of the detections that you do, so that you're able to track them even as they move around. So one is everything is static, right? And let's say maybe the camera moves slightly, but the objects itself are static. For instance, a camera which is fixed somewhere and it moves slightly and there's not much of movement in the scene itself. The other could be something like a camera in a vehicle, where the vehicle is moving, therefore the camera gets a lot of different frames with time. The surroundings also move, right? The vehicles that are coming close may move, may change from frame to frame. So you might have movement due to either or both of these. So it's very important to be able to uniquely identify something. We'll talk a little bit more about this in the later part of the lecture, but this is the idea. Again, what are some challenges in doing this? So the tracking speed, right? Again, how well you're able to track it across frames, and things like background distractions. So the background might keep on changing, right? And you might have a lot of visual effects. For instance, occlusion, where let's say suddenly a pole comes into view and the thing that you've been tracking is partially occluded. So when I say occluded, it's no longer visible clearly, right? It's sort of covered or eclipsed by some other object. That's occlusion. So you might have things like that, and you might have things like different spatial scales and different representations. So object tracking is very tricky in all of these, due to all of these reasons, right? The background could change, your object could get occluded, and the angle of the camera in drones and things like that, it's also 3-dimensional, right? You have 3-dimensional motion, so this spatial scales and things like that could also change a lot depending on the height of the drone. So all of these lead to problems with object tracking. So now we'll talk a little bit more about the stages. Occlusion means you can think of it as being eclipsed or being hidden, right? So if I have an object that's here and something else comes in between the camera and the object, so that you're able to maybe see part of the object but you're no longer able to see the full object. So that's an example of occlusion. So in that case, how do you continue to track it accurately, and you're still able to detect it across frames, right? That's the challenge that we are talking about here. But occlusion refers to part of the object being kind of hidden from the camera. Anchor boxes, I am not really sure what is the issue there. Right, I think it's this whole anchor and bounding boxes is this box that you draw around the object, right? So that itself sometimes may have some challenges. For instance, I see a car here, but the bounding box might include part of a bicycle, right? So do I draw the bounding box this tightly? Do I draw the bounding box this tightly? Those are some things, right? And I think there are a lot of other challenges that also come into play depending on the shape of the object, the size of the object, right? And sorry, I lost the slide. And that might also cause issues. So I'll see if I can share a link about this. Yeah, I think this towards data science post has examples about anchor boxes and what they are. Yeah, so you can go through this and you'll kind of understand what is an anchor box and also what can be some potential problems with drawing these anchor boxes. Okay, so the next stage is the designation or the detection. So the first stage, not the next stage. So here what you do is you identify a target of interest and you highlight it. And your algorithm, whatever you're using, analyzes input frames to identify the objects that belong to target classes. Bounding boxes are used to perform detections as part of the algorithm. So the same thing that we were earlier talking about, right? If I detect a car, I draw a box around the car to say that I have detected a car. That's kind of how object detection is typically done. The next part is the movement or the motion. So feature extraction algorithms analyze detections to extract appearance and interaction features. A motion predictor in most cases is used to predict the subsequent positions of each tracked target. So after you detect a car, you use a predictor to kind of predict where the car will be in the subsequent frames. That's the second stage. Then finally there is recall, where you use feature predictions to calculate similarity scores between two detections, right? So you basically want to find out if these two detections are of the same object. So how do you do that? You use these features and you calculate some similarity score between two detections. Then based on that score, you can associate detections that belong to the same target. You can say with conviction that these two detections are of the same car. So a lot of steps are involved in this, and things like identifications are assigned to similar detections, the same identification, and you could assign a different ID to different detections. So that's the whole idea. Similar to ML, yeah, kind of. So next we'll talk about video classification. So just like you had image classification where you would classify an image into different classes, right? Maybe cat, dog, that's the simplest example. Here you're classifying a video. So what do you mean by classification? In this context, it is used in the sense of producing a label that is relevant to the video given in the frame. For instance, it could be a boy playing cricket, right? That's a label that's relevant to the video. If you look at the frames where the person is playing. So good video classifier is not only one that provides accurate frame labels, but also describes the entire video given the features and annotations of the various frames. So it's not just frame labels but also an overall description, right? So for instance, I might give you frame by frame description saying person swinging his arm or person catching a ball and things like that. But what might be more interesting for the general user is to first get a summary of the video. So it's not adequate if your classifier is able to say you're swinging your arm, you're catching a ball. Should be able to identify the whole game as such and give you a compact description. Multiple object tracking, this stage will be applicable not for single object tracking. The classification part, is it? Or the three stages that we discussed here? I'm guessing you're talking about these stages, yeah. Okay, so here, yes, this definitely applies to multiple objects, but even when you talk about a single object tracking, you would have these stages, is what I think, because you need to track that particular. You might be interested in one object out of 10, right? But you will still need to detect it, you will need to predict its motion, and you will kind of need to see if it's the same object based on some score. So I think it should be applicable in both multi-object and single object tracking. Any reason why you think that it shouldn't work in one of the cases? Just curious, I might miss some corner case. So if you have something in mind, you can tell me and then we can think about that. Looking at it, I think it should definitely be there for both cases. In single object, read as manual steps. What manual steps exactly? Let me see if there's a slide on this. No, I think I've included everything except the demo parts of it, which you anyway saw as a video. I think this would be a single and multi-object tracking. Yeah, I don't see any other slides talking about both of them separately. Okay, not automated as 3 stages. Manual depends on the object tracking case. You could do it manually, but you can also do it as this pipeline itself, even if you have a single object. So I don't think that this is something specifically intended for multi-object tracking. I still think that it would work in single object tracking. You could choose to do it differently, and that's possible even with the multi one, right? But I think this would work for both cases. Okay, so let's go back to video classification. Next, we'll talk briefly about central processing versus edge processing. You worked on both cases in After Effects. Okay, I'm not sure what's the After Effect. Okay, we'll keep going, and if there's something on chat, we can look for it. So you can either run this centrally, right? Basically using servers that are located in some monitoring station. This would be central processing. After Effects, okay, as in video editing or video making, okay. So you worked on both cases, as in single object tracking and multiple object tracking, okay. And do you have a comment on whether it can be done on both in the 3-stage thing that we discussed, or if is something from your experience saying that it cannot be done in that way? Okay, let's keep going. So worked on first, second, third and fourth stages. Okay, So I'll take that to mean you've tried that out in both the single and multi-object, and I kind of also expect it to work in both cases. So yeah. So as we were saying, we could do this centrally on a server, or you could do it on the camera itself, right? So a lot of cameras may come with some small amount of compute available, right? Basically an edge device that's available with the camera. So you could process data there itself, which is again comes back to our whole edge AI deployment. So this is called edge processing. So you could do it centrally or at the edge. Those are two ways in which you could process. So with this we come to the end of the first part of your week 11. So now we will move to the deep stream part, and we'll try to do this quickly because we need to go through the questions also for this week. So deep stream is again a toolkit to do a lot of the things that we discussed, right? It's from NVIDIA, so it simplifies the development of your video analytics applications. So developers can use this toolkit to quickly build new applications. And again, what kind of applications? You could do image classification, scene understanding, content filtering, etc. So deep stream is based on the GStreamer framework. We will see other modules of GStreamer and how they are used in the deep stream pipeline. And deep stream is also part of NVIDIA Metropolis, the platform for building end-to-end services and solutions to transform pixel and sensor data. There's a comment, third is not there, single, double, fourth and multiple detection. Okay, you can do it in various ways, so that's fine. Repeat this part. So the broad takeaway is deep stream is an NVIDIA toolkit for video analytics. You can use it for various applications that we discussed, right? Classification, categorization, filtering, etc. And internally it uses GStreamer. So what does the GStreamer graph architecture look like? I'm not sure if this is very clear, so let me zoom in a bit. So you could have stages like this, right, where you capture the data, you decode the data, then you might do some image processing on it, like you might scale it, you might crop the image, then you might do batching, which is basically group a set of images to form a batch, then you put it through a DNN, one or more DNNs, to maybe classify or to segment or to detect, and then you might do tracking across frames, and then you might do some sort of visualization, and then finally you might either display that visualization, you might store it, or you might send it to the cloud. You might send, for instance, video data is often like sent to cloud for archival purposes, right? So you could do something like that. And here you see the hardware that's there for each of these. For instance, a capture is typically done with CPU. The decode can be accelerated, just like you have a GPU. You could have a decoder hardware which can accelerate this. Similarly, you have various custom accelerators. For instance, this DLA is a deep learning accelerator. It's intended to accelerate matrix multiplication primarily. And yeah, you see various other such things, right? WIC and ISP and things like that. And your output could be on HDMI, or you could send it to a SATA storage device. So this is broadly the graph view of deep stream. So if we talk about a reference application, so again going back to deep stream, it is a GStreamer based solution. So it consists of GStreamer plugins that form a complete graph. So this graph that you saw, right, each part will map to a GStreamer plugin, and we will come to that a little later in the slide. And this application that you have, you could like kind of configure it however you want, right? And it also has some pre-built inference plugins. This is a good starting point for you to explore deep stream, and you can tailor it however you want. So this is again very similar to the pipeline we saw, so we'll skip it. The only difference is here you have an option for edge versus cloud is clearly indicated. Okay, so yes, this is the plugin part I was talking about. we have a question. What is GStreamer? So you can again think of it as a library, right? So you have DeepStream is your higher level library or toolkit that has all these stages. Each of these maps to a GStreamer plugin, which is a low level library that gives you all of these functionalities. So if, for instance, I have video decoder, video decode stage, that would map to a GStream URL decode plugin. Similarly, your stream multiplexing would map to NV stream mux, and you have various other examples here. Object tracker maps to GST NV tracker plugin. Detector maps to NV infer. Secondary classifiers, tiler, on-screen display, renderer. So each of these high-level APIs or stages in the pipeline map to various low-level GStream plugins, GStreamer plugins. So here we have again a list of plugins and that are available to you as part of the DeepStream SDK. So the Stream Muxer plugin, which again we saw in the previous diagram, it forms a batch of buffers from multiple input sources. So here we not only saw output, but we also saw that we could have multiple cameras, right? So the Stream Muxer plugin helps you to sort of consolidate these multiple input sources. Then you have a pre-process plugin which helps you do pre-processing for inferencing. Then you have a TensorRT based plugin, NVInfer, for again primary and secondary detection and classification. Then you have an OpenCV based tracker plugin, NVTracker. You have a multi-stream tiler plugin for forming a 2D array. On-screen display plugin to draw boxes, rectangles and text based on the generated data. Finally, a message converter and message broker to send data to a server in the cloud. And again, what does DeepStream SDK help you do? It's a flexible and powerful SDK, so you could use it for a multiple of use cases and low code programming. So a developer can implement all of these by simply using the UI itself, right? That's what is spoken about here. Graph Composer's simple UI. So you could drag and drop individual boxes and you don't need to write a lot of code. Gives you a lot of real-time insights, helps you manage AI services, and also helps you train with Tau toolkit. So that's the features. Again, why use it is closely related to that. So development is very seamless. Repeat last 2 pages. We are running behind a little on time, so we'll see, maybe we can come back. Yeah, I'm kind of intentionally trying to speed up because I think we have to start going towards the questions over this week. So we'll try to come back to some of these slides through the questions. Anyway, the questions will cover some of these points. And okay, the other reason is to have, but I'll try to go a little slowly. Let's see how many more recap slides we have. Yeah, we are almost at the end, so I think we are okay on time. So the other part is that you can use Graph Composer, which is the UI tool that we spoke about in the last slide also. A programmer can basically implement whatever they want to using the UI tool without writing a lot of code, right? And you can construct complex pipelines and applications just using the GUI. And then it gives you an ability to securely manage apps and services. So it can run in various clouds as well as at the edge. You have messaging abilities between the edge and the cloud. You can also use things like recording, over-the-air update for the app or the models, and it gives you a provision for secure IoT device communication. So these are all various features and reasons for you to consider DeepStream. Overall, it gives you the ability to build end-to-end AI solutions that are very powerful and that help you speed up the overall development effort. And reference applications, the DeepStream app is one starting point that you can look at and then customize. And they also have Docker containers available for the discrete GPU. The DGPU stands for that. I think there was another slide which also showed about containers for the edge GPU. So these are various things. Each of these containers have different varieties, right? For instance, this says base, this says developer, this says Triton, IoT, samples. So depending on what libraries you need, you might choose between these container images. Okay, so with that we are at the end of the recap session. Any other questions before we move to the problems for today? DeepStream SDK for multiple programming options. Let's see where that is. Which slide particularly? So this one is again very similar to whatever we discussed previously, right? So it's a very flexible SDK, meaning that you can customize it for a broad variety of use cases. Low code programming, you have the visual graph composer, so you can build complex pipelines using that. Real time insights, it helps you process different sensor data and understand it. Managed AI services, you could do this using containers, orchestrate during using Kubernetes. You could also train with Tau toolkit. Okay, before deep SDK, which part was that? Multiple programming options. Was it this part? Okay. Which was the multiple programming part that you are referring to in this slide? So one way I can interpret the multiple programming is basically different use cases, right? For instance, image classification, content filtering, video categorization. You can use it for any of these. The other thing you can do is to build pipelines for any of these that are different, right? That's also a different sort of programming that you can do with DeepStream. You can come up with complex pipelines theoretically and be able to implement that using the, not in the slide, it was in the documentation. If you can send me a link to that, maybe I can understand that better. Let me look it up and see if I find something. Okay, I think what I see at first glance is just the option to use this graphical interface that we spoke about, right? Graph composer, or that you could also write code in either C or C++ or Python. So that might be the multiple programming that you saw mentioned there. That's the only thing I can find at a very first glance. But if it was something else that you saw, please like paste the snippet and maybe a link, and then I can contextualize it better. Okay, after that, last page. Okay, let's go back to the last page. The last page was this Docker container. So we were just saying that there are various images available for, not this, okay, which one was it? This one? This one? Okay, this one, the plugins. Okay, so again this diagram, right, this is explaining this diagram verbally. So you have various stages in the GStream pipeline, and each of these map to a low level GStreamer plugin. So this slide tells you about what are those plugins. I will go through two of them and then you can read the rest. It's self-explanatory, right? There is a plugin name and it says what the plugin does. For instance, you have a TensorRT based plugin which is called GST NV Infer, and this can do detection and classification. Let's look at the stream muxer. So you have multiple inputs coming in here, and the stream muxer can kind of merge these multiple inputs to form a batch of buffers. So that's what it does. You can see the stream mux here. So you can see two inputs going here, and then it gives you a batch of inputs, right? So all the plugins or most of the plugins listed here have an explanation in this slide. So you can go through that. Okay, with that we will move to the questions. Which of the following is true about computer vision? Acquisition, camera, pre-processing ML model, deployment, edge devices. Any answers? D, A, B and C. Okay. D. Okay. Anyone else? Let's look at the answer. It is D. Acquisition happens using a camera. Processing is typically done with an ML model. Deployment is maybe a little tricky because we spoke about edge and cloud, but deployment being done on the edge is a valid use case, right? So if you think about it like that, A, B and C is a good option. So that's the answer for the first question. Let's move on. Stages of object tracking include designation and motion, motion and detection, designation, motion, recall, recall and motion. C, designation, motion and recall. Okay. Anyone else? B, motion and detection. B, okay. Okay. So the answer is C, designation, motion and recall. Since many people are confused by this, let's look at why, right? So what are these stages? So first of all, designation is also called detection. So this is the first stage where you identify a target of interest. Then you kind of detect you use a motion predictor to predict the positions. Then finally there is this recall where you calculate these similarity scores between subsequent detections, and based on these scores you might say that two detections belong to the same object. So for instance, you could have an ID assigned to a detection, right? So you could say that this detection of a car is 1, this detection of a car is 2, right? And in the next frame I might, if my similarity score of this object and this object is high, I might also call this ID 2, right? So this is part of recall. So basically you are trying to calculate a similarity score between a couplet of detections across frames, and based on these frames you associate detections that belong to the same target. For instance, if both of these belong to the same car, you will assign them the same ID and you will say that they belong to the same car. So this is the final stage of object tracking, recall. So that brings us to the answer that the three stages are designation or detection, motion and recall. So yeah, I hope recall is clear now. We went through it. Not clear. So recall is basically, for instance, right, you trying to remember is a very simple explanation. For instance, let's say you saw a car in the morning and you saw it 5 minutes later again in the road, and now if I ask you, is this the same car? Basically I'm asking you to recall if this detection is the same detection that you saw previously. This is the model trying to do the same thing. How does it do it? It uses something called a similarity score, right? It gives, if for instance, a very simple way to think about it is to give an ID to the car. Maybe that ID in your mind was a license plate, right? So you saw the last 4 digits of the license plate was maybe 1002. So if you see another car with the same thing, you are more inclined to think that these two are the same object. Similarly, the model will also use some features to assign some similarity score and say whether these two are the same object or not. That is your recall stage. So the answer is C, not B, because all three are part of the object tracking. Detection is also called designation. That might have been the other reason why you guys found it confusing. Okay, third question. Dash is the task of producing a label that is relevant to the video given as frames. Detection, analytics, tracking, all of the above. D, all of the above. B, video analytics. Okay. Anyone else? D, all of the above. This one also seems to be confusing. Let's look at the answer. So it is B, video analytics. Let's go back to the definition where we had various right. So we had this slide, for instance, right, where we spoke about the various things that can be done, and video analytics is kind of a broad umbrella where you could do something like detection and call it video analytics. You could do something like tracking and also call it video analytics. But coming to the specific thing that we were looking at, so we spoke about detection and what it is. Detection is locating an object in an image. Tracking is kind of monitoring it across multiple frames. Then we also spoke about classification, and this is actually the closest to what the question asks. The task of producing a label that is relevant to the video. But if you notice in the options, that is not given, right? So then what is the closest that you can get to it? Video analytics, because it's like the umbrella term that encompasses all of these, right? So for instance, if I gave you the definition of object detection and asked you what is this, but did not give you an object detection as one of the options, video analytics is the closest option because it's like the super class, and this is one part of video analytics. So that's the answer. Hope that's clear. Okay, let's move on. Which of the following are challenges in object tracking? Training and tracking speed, background distractions, viewpoint variation, occlusion. And you have various options. D, all of the above. All. Anyone else? All. D, all of the above. Any other answers? D. Okay. This is unanimously agreed as D. So yeah, we also went through all of these. So I think it's fairly clear to everyone. We'll move ahead. The deep stream reference application is a dash based solution. M stream, X stream, L stream, G stream. D, D, D. Any other answers? D. Yes, it is a G stream based application. Which of the Docker container has all features of Deep Stream SDK? Base, Triton, Devel, IoT. So we probably skipped through this slide, but A, base, D, IoT, D, IoT. Okay. you don't know, that's also okay. So the answer given is base. So let's go back to the various things that were given. So IoT, which was one of the options, it is specific to IoT, right? So it's not what the question asks for. It asks for what contains all the features of the deep stream SDK. IoT therefore is not the answer. Triton similarly contains the Triton inference server and dependencies. So again, it's not a complete thing. So I think the answers that remain are base and devel. Let's look at that. Base Dockers contains only the runtime libraries and GStreamer plugins. Contains the entire SDK along with development environment for building deep stream applications. So from here, I still feel that base and devel can be valid options, but let me look and see if there's some additional documentation that tells you why it is base and not developer. I can't find valid difference. I'll double check the answer key for this. Base is a valid option definitely, but I think Devil also has all features, at least from the limited explanation that is given in this set. It also contains the entire SDK. It's just that it has a development environment where you can change and build deep stream applications, right? So I'm not very sure why it is. Where can I access the revision PPT? Are you talking about this slide deck? Oops. This one. So this one is typically uploaded to Drive after the live session with all, so that my annotations are also captured. I've just shared the link with you. You will find week 1 to week 10. Week 11 will be uploaded after this session. So this one I'll double check, but for now the answer is base. Let's move on. Which is the GStreamer plugin to form a 2D array of frames? You have 4 options. Any answers? C, multi-stream tiler. Okay. C. Yeah, that's okay. Sometimes the names are obvious enough that you can get it right, or you can try and eliminate if you know some of them. Okay, I think everybody has answered. Let's look at the answer. It is multi-stream tiler. Let's now go back to that slide which had all of these. Right, this was the one. So NV Stream Mux was one of the options. We went through that one, right? It takes multiple inputs like here and merges them to form a batch of buffers. So that's not the one. That's not talking about an array of frames. The other option was NV Infer. This is this TensorRT based plugin that helps you do detection and classification, right? That's also not the one. The other option was NVD SOST, and that draws these shaded, so it stands for on-screen display, right? So it draws all these shaded boxes or rectangles or text based on the generated metadata. Again, that doesn't talk about a 2D array of frames. So the multi-stream tiler is the one that's responsible for forming the 2D array of frames. So try and remember based on the name what it does, right? That's the easiest way for you to eliminate or shortlist options. So now coming back to our question, we'll see that the answer is multi-stream tiler. Next question. Which is the GStream plugin to establish connection to the cloud and send the telemetry data? This is from the same slide again. Do any of you remember? Okay, B, NV message broker. Yeah, again the names are kind of fairly leading. So try to pay attention to the name and see if you can figure out. Okay, don't know. Anybody else? Okay, if not, let's look at the answer. It is NV message broker. So let's again go back to the same slide. So message conf was also one of the options. This one is a message converter and this is a message broker, and your explanation tells you that these two in combination send analytics data to a server in the cloud. The other two options are straightforward to eliminate. NV infer was one of the option. Again, that is used for inference things, right? Basically detection and classification. That's not for connecting to the cloud. That's a straight out no. Similarly, you can eliminate NV tracker because this is the one that does the object tracking with unique ID. So both of these you can eliminate out. Message converter and message broker is where you might slightly be confused, but message converter is not the one that does this core functionality of establishing a connection and sending the telemetry data. It is message broker. So that brings us to just one option, and that's why the answer is message broker. Hope this one is also clear. We move to the next question. Which is the NVIDIA framework that simplifies the development, deployment and scaling of AI enabled video analytics applications from edge to cloud? We looked at this also in the recap. Does anyone remember? Okay, B, Merlin, A, Metropolis. Anybody else? B, Merlin, okay. D, Dali, okay. Again, a lot of these names are there throughout the course, so you might find it confusing. No worries, let's look at it. It is A, Metropolis. So again, this was there I think in the slide with an introduction to DeepStream, right? This part. DeepStream is an integral part of NVIDIA Metropolis, which is the platform for building end-to-end services and solutions for transforming pixels and sensor data. So this is the framework. The other options, again, some of them you may or may not have encountered through the course, but I would recommend you at least like note down a one-line description of it, right? For instance, DALI is NVIDIA's data loader. Riva you may or may not have. Riva and Merlin you may or may not have encountered. But whenever you see new things that you are not familiar with, it would be good to get a one-line understanding of it, because next time you see a question like this, you'll be able to quickly eliminate out the other options. These might not be part of your subject itself, right? The course content strictly, but it will help you because you will be able to eliminate it out, especially when you have options starting from the same alphabet, right? Everything sounds from the same letter in the alphabet. It might sound very confusing, like Metropolis and Merlin. Even if you heard the name, you might get confused. So it'll help if you do a little bit of pre-work and look up what are these extra things. Okay, with that we move to the last question. Deep stream pipelines can be constructed using VPython, CPython, GST Python, Cython. C, GST Python. Anyone else? GST Python. C, GST Python. C, Python. Okay. Okay, let's take a look at the answer. It is GST Python, which basically stands for GStreamer Python. So remember we spoke about how GStream is made of low-level GStreamer plugins, right? So you can construct these pipelines using GST Python. And with that we come to an end of the questions. So we have 10 more minutes left. So if anybody has any other doubts or questions either pertaining to this class or with respect to the later revision class, please again put it in chat. Okay, someone has put an explanation for Merlin. Merlin Huge CTR is a DNN framework designed for recommender systems on GPUs. Great. You can copy out some definition like this and keep it so that you can revise it quickly few days before the exam. Questions of previous week. Are these assignment questions you're referring to? Week 9, is it? Okay. Are there doubts in specific questions, or would you like me to discuss all of them? If you give me specific questions, it will be easier. That way we'll have time. Do people have doubts in the week 10 assignment? Yeah, sure. You can take a couple of minutes. I'll hang around on the call. And if there are people who have no questions or doubts, feel free to drop off. Thank you so much for joining, and see you next week for the last live session. And I'll wait around for another 2-3 minutes. So any general questions, anything that's not clear, feel free to put it on chat. Okay, Levenstein distance. Okay. Okay, got it. Yeah, we can definitely cover this one. Next week also there is this problem where the last year's content, like I mentioned at the beginning of the session, last year's week 12 was federated learning. So the previous year's assignment is all federated learning. And in week 10 we went over those extra questions with Dask because you at least had an introduction to Dask. But this week I think since you have not at all studied federated learning, it may not be very useful to go through those. So we might have a bit of extra question. So we might have a bit of extra time. So I can definitely go through some of the questions that are there in week 10. Thank you so much, and thank you for writing all of this out. Definitely makes me feel very happy because it takes a lot of effort to prepare and kind of deliver these live sessions. So I'm really happy to hear that it made a difference. Thanks again for the very nice message. Another question on structural ambiguity. Yes, we can go through this one too. And week 8 assignment. Again, are there particular questions in week 8 assignment? That's all right, as long as you benefit from them either by attending it right away or by watching videos on YouTube. That's perfectly fine, whatever works for you. Yes, the revision session, that's why I asked today for questions. So that's an optional thing that the TA, that I can decide to have or not. So that's why I kind of wanted to get a sense of what questions you guys have and things like that. So since there are enough topics that people want me to cover, we will have a revision session. But again, like I said, it won't be a session where we go through all 12 weeks because we won't have enough time to do that. So instead, I will focus on specific questions or doubts that you guys have asked today. And in the next class, if you have some, you can ask there also, but that will be a little tricky because I'll have to have the live session in the same week, so we might get 1 or 2 days gap between the next Monday and this session, right? So I would prefer if you ask it today. Last week also you asked about week 8. Oh, I noted it down, but I don't remember there being a week 8. I remember only the hyperparameter tuning and the this one. So I don't, and I remember the CNN numerical part. Week 8 we can go through it. Again, are there specific questions that you would like me to cover? So I hope the revision session part is clear now. We will have one, whether it's 1 hour or 2 hours, we will see that depending on my availability and what NPTEL is asking. DSSDK means Deep Stream SDK, probably. I don't think there is anything else that stands for DSSDK. Yes, the above, whatever is asked on chat, I have definitely noted it down. So week 10, what questions you guys have a doubt is very clear to me. Week 8, I wanted to know, since one of you asked, are there particular questions that, if you mentioned it in the last week, then I can go look at that. But if not, I would appreciate it if you can give me particular questions from week 8. Okay, that's the question. The learning rate. Okay, this one. Sure, we can go through this. Sounds good. Any other questions? I'll wait for another minute or two. Yes, sure. If you have more questions, please post them. Between next week and the revision class, we'll try to cover all of it. You're very welcome. Hope that it's helped you. And all the best for the upcoming exams. Last time, I don't remember any other question. Site for the recordings, they are on YouTube. Let me give you the link. Yeah, I've pasted the link on chat. You will find all live sessions. Typically, I upload them within 1 or 2 hours of the class. So you'll find them there. Last time you asked other questions. I'm sorry, I don't seem to have noted it down somehow. I usually have everything noted down. Not sure how I missed it, but if you can paste it again. Right. This was the this was what I mentioned here, right? This is the second doubt that was asked today. So this part. This was a numerical that I had kind of put in. Yeah, that's not very relevant for this course. So we will keep this to the revision session, and I will rediscuss this question. But please remember that this is not very relevant to this course. It will just help you understand CNNs and how it processes things. It maybe help you understand that better. So keep that in mind. One more, how many hours for 3 epochs our training is required when batch size is so much and time taken for each iteration? This also we can go through. I think it was there in one of the live sessions. Can you give me the week number of the live session? Then I can kind of look back at that question. Which technique should be used to reduce generalization error? Yeah, this also we can go through it. No worries. Yeah, your question is week 8. Yeah, that is clear. This one, I think it's from an earlier week 4, is it? This, how many hours for 3 epochs of training? Please share. I'm not sure which one you're asking about. If you're asking about the numerical, there is an entire tutorial with such numericals which you might kind of benefit by seeing, and you can watch that video and you'll find a lot more there. Yeah, I think this TensorFlow XLA you kind of asked earlier. I will again cover that in the next session. Now, unfortunately not. I have a 9 o'clock meeting, so I have to jump off in a few seconds now. I'll keep the chat active for another 30 seconds. So if you have any last minute questions, you can paste it there, and then I'll take it, copy it from there and get back to it in the next 2 sessions. Don't worry, we have 2 more, so I'll make sure to cover all your questions. So with that, thank you so much for attending today's session, and see you guys in the next session. Sure, you can.